Have you ever tried guessing what's inside a wrapped gift without opening it? Exciting, right? You shake it, you feel it, you make your best guess. Well, that's exactly how scientists were with atoms, full of curiosity. For thousands of years, nobody could see an atom. No microscopes powerful enough, no cameras, just mystery, just invisible building blocks of matter. Fascinating, isn't it? But scientists didn't give up. They kept guessing, testing, and updating their ideas, like solving a thrilling mystery. Today, we're jumping into a time machine to meet 5 amazing scientists who helped us understand what atoms are really made of. Ready? Let's go! First stop, 1803. Let's travel back in time. Meet a man named John Dalton, an experiment-loving schoolteacher. Dalton was a schoolteacher who loved doing experiments, always curious. He said, "Hey, maybe everything is made of tiny solid balls called atoms." How cool is that? He thought atoms were like marbles, hard, round, and couldn't be broken. Imagine that. Each element, he said, had its own kind of atom. Hydrogen atoms? All the same. Oxygen atoms? All the same. But different from hydrogen. Dalton's model was simple but smart, genius in its simplicity. He couldn't see atoms, but he could tell how they behaved in reactions. Science in action. Imagine making Lego models with one color per block type, no mixing. That's how Dalton saw atoms, small, indivisible blocks. Today we know atoms aren't quite that simple. But Dalton got the idea rolling. Amazing start. Next stop, 1897. Say hello to J.J. Thomson. Thomson was playing around with electricity and glowing gases when, zap! He discovered something shocking. Atoms aren't just solid balls. Inside them are tiny negative particles. He called them electrons. He imagined the atom like a muffin or a chocolate chip cookie, a positively charged dough with negative chips, electrons, stuck inside. He called this the Plum pudding model, because in England, plum pudding was a thing. Thomson's discovery was huge. He proved that atoms could be broken down into smaller parts, and those chips he found, electrons, are still used today in everything from TVs to phone screens. Now hop back into the time machine. Next stop, 1911. Meet Ernest Rutherford, the atom detective. He did a wild experiment called the gold foil experiment. He shot tiny particles at a thin sheet of gold and expected them to go straight through like bullets through tissue paper. But some bounced right back, like ping. What was going on? Rutherford realized. Atoms must be mostly empty space, with a tiny super heavy center called the nucleus. The electrons? They move around the outside. Forget cookies. Rutherford's atom was more like a bee flying around a tiny flower. He gave us the idea of the nucleus, the dense heart of every atom. And today we use that idea in everything from nuclear energy to medical treatments. Jump ahead to 1913 and meet Niels Bohr. Bohr was like the kid who loves organizing things. He looked at Rutherford's model and said, "Cool, but what if electrons don't just fly around randomly?" He imagined them moving in set paths or orbits, like planets around the sun. Each orbit had a different energy level. Electrons could jump from one orbit to another by absorbing or releasing energy, like little rockets blasting off to a new level. Bohr's model helped explain how atoms emit light, like in neon signs, glow sticks, or fireworks. Thanks to Bohr, we began to understand atomic energy better. Huge for chemistry, physics, and future tech. Okay, hold on tight. Our last stop? The modern quantum model, also called the electron cloud model. This one isn't named after one person. It took lots of scientists, like Schrödinger and Heisenberg, working together. They said, electrons don't move in neat orbits like planets. They're way more unpredictable. Instead, they move in clouds of probability. We can't say exactly where an electron is. We can only say where it's likely to be. Kind of like tracking a buzzing fly in a dark room. So now we don't picture electrons on tracks. We see them in clouds, swirling, buzzing, zooming in all directions around the nucleus. This model might sound confusing, but it's how scientists understand atoms today. And it's the key to building quantum computers, lasers, and the next generation of technology. Let's do a quick recap of our atom adventure. Dalton, atoms are tiny solid balls. Thomson, found electrons, it's like a chocolate chip cookie. Rutherford, atoms have a nucleus, mostly empty space. Bohr, electrons move in orbits like planets. Quantum model, Electrons move in clouds. They're wild and fast. Each scientist added a piece to the puzzle. And today, thanks to their work, we can understand chemistry, make medicine, build electronics, and even explore space. Science keeps changing, updating, and growing. Because the more we learn, the more we realize how much more there is to discover.